Now we will proceed with the first panel, the Northeast Asian Semiconductor Triangle, Cooperation, Competition, and Strategic Balance. Let's welcome all the panelists for the first session to the stage. Joining us today are Dr. Jeremy Zhang, the CEO of DSET, as well as the Director for the Economic Security Research Program. Dr. Zhang will also be moderating. We also have Ms. Zhen Tingfang, Chief Technology Correspondent at Nikkei Asia. Dr. Seok Joon Kwon, Professor in the School of Chemical Engineering at Sunggungwon University. And Professor Hideki Wakabayashi, Distinguished Professor in the Research and Education Institute for Semiconductors and Informatics at Kumamoto University. This session analyzes how Taiwan, Japan, and South Korea navigate escalating export controls and the drive for technological sovereignty. It explores the strategic adjustments each actor is making to balance national economic security and maintain their collective indispensability in the global supply chain. Please once again, welcome the first panel. The floor is yours, Dr. Zhang.
So good morning, distinguished guests, colleagues and friends from Taiwan, Japan, and South Korea. I'm Jeremy Chan, CEO of DSET. Well, this is my great honor to welcome you to the first panel of this Taiwan, Japan, Korea trilateral technology dialogue, focusing on one of the most strategic issues shaping our region and the world, the future of the semiconductor supply chain. Today's gathering is rooted in its shared foundation. Taiwan, Japan, South Korea are not only technology leaders, but also democracies committed to openness, rule of law, and the belief that advanced technology must strengthen, but not rather than threaten our societies. So this shared value is what gives meaning to our collaboration. We've been in a very, very unprecedented moment as AI booming is really dramatically to reshape our supply chain and our economies. Taiwan, South Korea, and Japan, now we are jointly as a center for advanced manufacturing. We're not only taking the benefit from the AI boom, but also we are facing a common challenges from the current geopolitical landscape. So this is a very exciting moment for us to sit together to discuss about whether there's a possibility for these three Northeast Asian countries who are currently dominating the semiconductor manufacturing and AI manufacturing to collaborate each other. Let me remind you, because the AI boom is really reshaping these other nations' economy. So Taiwan has already experienced continually 2 quarters of economic growth to achieve the 8% of the GDP. And also this year we are expecting that Taiwan's economic growth is going to achieve 7%. So this is kind of a remarkable moment for Taiwan. And if you look at the performance of the Japanese stock market and Korean stock market, it's also booming as well. But we cannot ignore that the current challenge we are facing is still many of the approaches deserve us to discuss together. Whether the AI booming is a bubble, whether the bubble disruption is coming, whether we have enough energy capacity for keeping running this economy without any disruption. Whether the future of the geopolitical landscape will impact the current development of our strengths here in this region. Whether we can still keep in this industry be so concentrated in this region. I think these are all very, very critical issues that deserve us to sit together. So we are very glad that we can have our guest speakers, our panelists today to discuss about this is one of the most critical issues, not only for Taiwan, but also for Japan and South Korea as well. So I'm introducing our distinguished guests today from this Professor Seok Joon Kwon, who is the professor of Seok Joon Kwon University, and Professor Kwon is the leading and one of the most well-known academia people from the academia that covers semiconductors. And I'm also the big fan of Professor Kwon because I'm keeping following Professor Kwon's thought on social media, covering about the semiconductor development and also about the geopolitics. Professor Kwon, 2 years ago or 3 years ago, released your book, mentioned about semiconductor geopolitics. The so-called the free kingdom of the semiconductor industry. It hasn't yet to be translated into the Mandarin version. So I was pushing Professor Kwon to translate your books, and then maybe we can have a book talk session together here in Taipei again. So I'm pushing you. And the next guest speaker is Professor Hideki Wakabayashi, who is currently the distinguished professor at the Research and Education Institute for Semiconductors and Informatics and Kumamoto University. So now everybody very, very well know where Kumamoto is, because TSMC is going to Kumamoto, and Kumamoto is going to be the destination for the Japanese semiconductor industry revitalization. And Professor Wakabayashi is not only one of the most well-known semiconductor analysts for decades, but also he's one of the core members that joined the Japan's semiconductor industrial policy making process to help the Japanese government for this critical policy issue now. So we're really looking forward to Professor Wakabayashi to share his point of view from Japan, not only the Japanese industry point of view, but also the Japanese policy making process point of view. And lastly, we have our distinguished guest from Nikkei Asia, Tim Fang, one of my close friend. So we've been frequently discussing about the development of semiconductor industry and AI and even robotics. You recently visited Japan for watching the development of the robotics as well. But we are focusing on the semiconductor today. So Tim Fang is a chief technology correspondent at Nikkei Asia. And so Tim Fang is going to sharing with us her point of view on the recent development of the semiconductor industry, and sharing this point of view from maybe Taiwan's perspective on what kind of a challenge that we've been facing today. Okay, so this session we're going to divide into 2 parts. I'm going to make this session as informative as possible. So the 2 sessions I'm designing into 2 parts. The first part we are mentioning mostly about the challenges. What kind of challenges that each of the country that is currently facing? What are the common challenges that we are facing? And so this is, I think this is one of the most critical issue that we have to discuss today. But the second session, we're going to focusing on whether there's a possibility for us to collaborate with each other. I think it's we've been collaborating each other, because of the markets here, and the market is pushing us to collaborate. But as we are jointly, to dominate the manufacturing part of the semiconductor and AI industry, from policymakers' perspective or from the industry participants' perspective, I think this is a kind of a critical moment for us to sit together to think about whether we can create a framework from an underground perspective to collaborate. Okay, so just let us directly get into the discussion part. So firstly, let me check my rundown. So maybe firstly, I'm having Professor Wakabayashi to to share your perspective from Japan. Especially, I remember your concept about the dual silicon triangle. This is a very remarkable concept because Hoover Institute has introduced the silicon triangle to mention that the US, China, and Taiwan is very critical. But from your perspective, especially a very, very underground perspective, you mentioned that Japan, Taiwan, and South Korea as a second triangle, and Taiwan is going to be the center of this dual triangle. And can you share a little bit about your perspective about why you created this concept, and from your perspective, what kind of a challenge that this concept from you that we can jointly solve the current challenge, and what is the challenges of us, especially for Japan? Yeah, thank you.
Can I use a slide? Okay. Thank you very much. Please skip. This is my background. So today I belong to the Kumamoto University from this April. Before that, 10 years I'm analyst and fund manager and academic. This is my introduction. Skip. So today, in 2020, Japan policy started the strategy from three aspects. First one is introduction of the TSMC to Kumamoto. Second phase is establishment of the Rapidus. The third step is optical electronics fusion, so-called NTT-IO. I think the step one is very successful. Now the key is step two. So then, okay. So this shows my concept of the dual silicon triangle. So USA and China, mainland China, and Taiwan is compete and complement each other. So I add the other triangle, Japan, Taiwan, and Korea. I think Taiwan is very strong in the foundry and fabless, a little bit fabless, and OSAT and EMS. However, Taiwan is a little bit weak in the manufacturing, equipment manufacturing, and the raw materials. In that case, Japan is Japan's in chip-based, chip semiconductors, the today market share is only less than 10%. However, still Japan keeps almost 30% in the semiconductor equipment, such as torque electron or screen, etc. And in the case of the raw materials, Japan keeps more than 50%, like Shin-Etsu or JSR, etc. That means Japan will contribute through equipment and raw material to Taiwan. It's a coexistence. And in the case of Korea, it's very strong in the memory, in case of Samsung and SK Hynix. That means we work together in the double silicon triangle, dual silicon triangle, I think so. So in the other hand, this shows these companies' positions. Vertical axis shows how is integration oriented or division horizon exchange. And then horizon axis shows vertical integration oriented or horizontal division integrated. In that case, Japan is a little center of this chart. However, China and Korea is a little bit vertical integration oriented. So in the case of Taiwan is more tangible and then horizontal division oriented. That means we coexist each other in position mapping. Okay.
Well, thanks so much, Professor Wakabayashi, for further explaining the concept that you mentioned previously, so the dual silicon triangle, and thank you so much for sharing Taiwan's position in your concept. And next, our guest speaker is Professor Kwon from Seok Joon Kwon University. Every of us know that currently the South Korea-Taiwan trade has just experienced a historical moment that I think since the end of last year, South Korea has replaced Japan as currently our number one sources of Taiwan's trade deficit. This is because the South Korea now is importing the HBM from Korea and then conduct a packaging process here in Taiwan. This is advanced packaging, and this is one of the most critical export now from Taiwan to the United States and our destination as our major industry now. But from your perspective as a memory champion, and what are the challenges that currently the Republic of Korea has been facing, and how do you explain and how do you interpret the current challenges, and what kind of a challenge that you can mention with us, and then if there is a possibility for collaboration.
Okay. So I am going to use my PowerPoint too, and can I stand up over there? Yeah, sure. Okay. Hello everyone. My name is Seok Joon Kwon from South Korea. And I'm happy to be here, and thank you for having me. And I'm working at the Seok Joon Kwon University. And today I'm going to talk about what is the common challenges we are facing, and what is the substantial roadmap for the challenges. Okay, so I would like to mention first about the singular point in terms of the technology. The first one should be artificial general intelligence or artificial super intelligence. And there can be some uncertainties around the sustainability for the profitability, and there should be some critical issues about the computing itself. It means that maybe we can face some technological limit. And finally, there is some uncertainties around this energy and sustainability. First of all, I would like to mention some core concept that we are facing the GDI instead of the GDP. So it means that we're going to measure the national power in terms of the gross domestic intelligence, not just the productivity or some production. So it's going to be some equation which is determined by some computing power C, and the other one is energy. And it means that there should be some kind of the multiplication. So it means that it's both the problems about the computation and the energy. And very interestingly, the US has advantage in computing, while China has advantage about this energy production. So it's going to be the game between this computing and the energy, and it should be a function of this economy and the profitability. And I think that in terms of the computing, the many are just focusing on the GPU itself made by NVIDIA. But now we need to think about that there can be some chain of a monopoly. So we can easily think about the NVIDIA is supported by TSMC, and they have the HBM from Hynix, and they both rely on the EUV lithography made by ASML, and there's some etching machine made by AMAT or Lam Research, and the software designed by ARM, and the Synopsys and the Cadence, something like that. And it means that this kind of the global supply chain is quite some monopoly-like one. So it means that there can be some variations around this global supply chain. Okay. Now we can think about that. What is the possible way for the evolution of the AI chip and the AI DC? I think that Professor Park will talk about more about this chain, but I'd like to think about that there should be some cost-effective or energy-efficient or job-specific ASICs, such as MPU or TPU or DPU or even LPU, which is actually LLM-specific processing unit. And there is some kind of the tendency around the world, such as sovereign AI, which means that there's some kind of the internalization of AI chip. And it means that they would like to make their own supply chain in their own country, and I think that one of the representative examples about this sovereign AI should be the PRC, and which is represented by the Huawei. And there is some very interesting tendency for the NVIDIA. It means that they are just making their CUDA and NVLink technological IP to the other companies since July 2025. And there will be the rivals against the Hynix, such as Samsung or Micron, and even CXMT in Paris will join the HBM supply chain in next year. Okay, so why memory is critical? So there should be the movie here, but I think that there's some technological issues. But the summary is that the memory is so slow compared to the other cores, such as a GPU or and NPU. And this is mainly due to some memory hierarchy. And there is some L1 cache or L2 memory, and even the large storages. And it means that the memory is too slow. Okay, there is some, sorry. Can you play this movie? Oh, there's no movie. Sorry about that. Okay. Anyway, you can find out that this kind of the memory, the wall effect, and the memory wall effect means that there should be the larger and larger discrepancy between the computational speed and the memory bandwidth. So that's going to be make some really critical issues about this energy consumption and the computing bottlenecks, something like that. And it means you can find out that on your left-hand side, there should be some compute core limited. And on your right-hand side, there should be some memory-limited one. And you can find out that the energy requirement between two entities is really 5 or 6 orders of magnitude discrepancies. So that will make some big problems for both the hyperscalers and the other AI consumers. So people are just looking for the other, I mean, the beyond the GPU, so such as GPU, TPU, NPU, or beyond. And one of the leaders in these areas should be Google. And they're just focusing on the energy efficiency or memory efficiency and the supply chain stability. But there is still uncertainties about the supply chain itself, because the Google would like to use TPU first for their own use, such as Google Cloud Service. So, and there's another uncertainty, such as a bubble or hype in AI chip or finances. As Dr. Zhang already mentioned, that there can be some possibility for the formation of AI bubble, and nobody knows whether it is going to be that it collapse down or not. And you can think about some kind of the situations, such as the ASI, which is just going up, and there is some continuous growth, which is a stable growth, and there can be some the collapse down situation. And nobody says no, but this should be some critical issues around the supply chain for the semiconductor in the Far East Asia. And I need to mention the energy and the sustainability issue itself, and it means that we are just supplied energy in a linear like behavior, but there is some exponential growth for the computational powers. So it means that they will make some big discrepancy between the computing itself and the energy, and that will make the discrepancies in the GDI. And I need to mention the common challenges such as technological limit, and actually this is the big problems because there's no clear roadmap after 2030s. And nobody is sure that what will be next in lithography techniques after EUV. EUV or the others, I don't know. But it means that we need to make some kind of the collaborative R&D for these issues. And I will talk about some solutions. So let's first talk about the first solution. And we make some kind of the substantial cooperations for the next generation technologies. And it means that we need to go beyond the current technology to find out some future technology. And this can be some kind of the combination of these photonics or some optical or the quantum computing or some AI-driven design of the advanced chips or something like that. And we can also think about some bottom-up approaches for the design of these nanometer scale or even or atomic scale chips. And I need to also think about some EUV lithography. And as I mentioned, there's no clear roadmap after 2036 or 37. And it means that we need to search for the next generation optics or even the E-beam-based approaches. And there is some kind of the alternatives, such as nano-imprinted lithography. And in this market, a Japanese company Canon is the upfront, and followed by the other lithography companies. And maybe we can think about it beyond the EUV, which means that we can pursue the short wavelengths, such as 6.7 nanometers, and it means that we can get some the higher resolution for the patterning, but this will not ultimately solve all the problems because there will be some issues about the materials and the optics issues. And it means that we can search so many uncertain drivers, the candidates replace this EUV lithography. And in the middle size, you can find the startup, American startup, the name, the X-Lite. Actually, very interestingly, this was founded by the former CEO of the Intel, Pat Gelsinger, a few months ago. And on your right-hand side, you can find out that there's some accelerate or synchrotron-based beam generations, such as XFEL, such as free electron, the light sources. And unfortunately, the mainland China is one of the giants in the development of the synchrotron or accelerator-based light sources. Okay, so let's talk about what is the potential, the trilateral, the corporations about this solution. So maybe we can first think about the new lithography, and we can think about the new memory to overcome the memory war effect, and we can also pursue the new energy. So let me talk about what kind of the memory, the collaboration among these three nations. Because we are looking for the next generation HBM, but there is some technological uncertainty that what will happen after the HBM4E. And this is actually the issue due to the packaging. So it means that we can make some solid collaboration between the Taiwan and even the OSAT-based equipment based on the Japan. And we can also pursue the fundamental science based on the acceleration. And actually, Japan is one of the leading countries for the accelerator, especially KEK or JPARC or Sakura, or something like that. And I'd like to mention that there's some possibility for the setting, the pre-standardization for the next generation technologies. It means that it will take at least 6 or 7 years to set a standard. And maybe we can pursue this trilateral, the collaboration to set these future technology standards. And this standard can be named the FAST. The FAST is the Asian Semiconductor Technology Standards. And we can share this standard or standard strategy to get the global market and to make some kind of the deterrence for PIC's standard the strategy. Now I would like to talk about the second option. Okay, so 10 seconds. Okay, it's okay. So I will stop about the second option, but I'd like to mention that the President Lee Jae-myung's administration of the RK, they would like to put more effort for the formation of this globalization of the semiconductor fab, as well as the sovereign AI, and it means that we are open to the FDI and the trilateral collaboration too. And I have so many PowerPoints right now, but the time's up, and I will talk about.
We actually have a second round, so you have a
Thank
second.
you. Thank you for your listening. Thank you.
Well, thank you so much for such an informative slides. I always enjoy it a lot. I hope we can have a longer time for you, but we're going to have a second round for this part. So Tim Fang, and so from your part, my question for you is from Taiwan's perspective, because we are now focusing on friendshoring our allies. So President Lai, I think 3 days ago, just mentioned that we are pushing for our concept of friendshoring our allies for semiconductor manufacturing capacity. You just visit Arizona, and I think we frequently visit Japan, Kumamoto, and Tokyo. So from your perspective, what are the challenges currently being facing, either from our friendshoring capacity there in Arizona or Kumamoto? And also, I remember you recently interviewed Pat Gelsinger when he was here last week. He mentioned about many perspectives about how the U.S. and Taiwan can join overcome these challenges. So the time is yours. Thank you.
Yes, thank you so much, Jeremy and DSAT's invite. Could you please help me bring up the slides as well? Thank you. Yes, so this one. Okay, just a briefly introduction of Nikkei Asia. It is Nikkei Group's flagship English publication for a global audience. And like Jeremy said, how to next? Oh, okay, right. So it's really an eventful time for people covering semiconductor supply chain. And I recently visited one of the hubs. It's Arizona in October, which is at the center of America's chip onshoring push. And it was a very interesting trip. Let me share a bit of a quick overview. First, Intel. I had chance to walk inside the clean room of their Intel's Fab 52 actually is where they just begin to ramp up the 18A or 1.8 nanometer chip production. Basically, it's for Intel's own products, laptop, and server CPUs for next year. So actually inside, you can actually see a couple of ASML's EUV machines on the line. And right now, it's actually the most advanced chip production happening in the US. TSMC and Samsung have not yet started producing this 2 nanometer family in the US yet. So if you drive about actually 40 to 50 minutes north from Intel's Chandler campus, I just show you, you will see a big red. Actually, it's the largest crane in the US. Then people told me whenever you see that big crane, actually it means there's a massive project going on. It's on the way. And in this case, it's TSMC's Lake Arizona campus. Actually, these are all photos from Nikkei Asia. And then also you can, so TSMC's first fab in Arizona, it's already producing 4 nanometer chips for Apple and NVIDIA's AI GPU. Also, a second fab and the third fab is currently under construction. And as soon as 2027, TSMC could probably start producing 3 nanometer and even 2 nanometer chip in the US because TSMC is looked to accelerate their US tech roadmap. Previously, the third plan would be 2 nanometer. So when the 165 billion investment is completed, people normally say it's 2032. So TSMC expects that about 30% of its most advanced chips could be located in the US. So if you visit there, you will find it's really still deep inside the desert, but the atmosphere is already like very different from my first visit back in December 2022. You can see big real estate developers already start to plan their hotels or shopping malls close by, and then you can also see thousands of employees coming into their complex to work every day. And then on the construction side, normally it's 5,000 to 6,000 construction workers on site every day. So on the surface, things looks they are progressing quite well, but the journey actually has not been like really easy. I met a lot of suppliers who were true pioneers, people who followed TSMC to the US as early as 2021. A lot of hard work has been there. So take one example is UIS, Hantang. Maybe a lot of people know about this company. They are TSMC's major clean room builders. Actually, at first, they underestimate and a lot of things like cost. They underestimate like time for various permits. They underestimate the challenge of finding subcontractors and the challenges of working with different culture. It was like super challenging at first for them. And they need to like find, work very closely with a lot of local government officials who had never inspected the semiconductor facilities before. Because Intel is close by, as I just mentioned, and around for years, but they are in Chandler, not in like Phoenix. It's a totally different jurisdiction. So something like very easy, like in Taiwan, that could approving a small area of electrical transmission could take 1 to 2 days. But at first in Arizona, take them like 3 months to complete. So don't forget, they also built the plant half through the COVID. So actually a lot of shortage of component problem did occur. And TSMC's chairman, C.C. Wei, did share that they spent 18 million USD just to hire specialists and work together and sit into the meeting to work with local government officials just to create regulations. So together they create 18000 rules together to govern the chip facilities. So it's TSMC paying money, drafting rules to govern and regulate themselves. That's just one vivid example of from the construction side. But you can also see from this chart, a lot of companies have committed to build facility over there. So you can see, but overall, only Changchun and then Sunlit have actually built the plants, are early movers, but a lot of them, like LCY Chemical and the Canton KPCT and Solvay, actually have secure land, but they have to put on hold the construction after facing a lot of challenges like labor shortage, rising material cost. So I actually visit Changchun's facility in Casa Grande. You can see it's like a 1 hour south of Intel's Chandler campus. So you can see that it's already being, but for like chemical suppliers, it really take a lot of time for their result to be paying off. Like even Changchun now is already ramping up their first phase of the ramp up of high-end chemicals. However, it will take them 1 year for the verification time. So every drop of chemical must match extremely strict protocols. So suppliers need to invest far early, but their return could be far away. So most suppliers still need to find more customers, and they hope that TSMC can, as promised, build so many facilities there so they can justify their investment. Okay, and then quickly look about Japan, because Jeremy also helped me to talk a little bit about Japan. So this is TSMC's Kumamoto plant have already been up and running, and then producing mature 28 or 16 nanometer node for Sony and Japan's automotive and industrial supply chains. They've also started building the second plant. So Japan's progress has been steady, but actually, for foundry, everything ultimately comes down to customer demand. So to be very honest with you, when you speak with supply chain people recently, they will tell you that TSMC's progress in Japan is a bit slowing, mainly because customers' demand is not that strong right now. As all of you know, most of the momentum today are in AI data centers. So demand in automotive, industrial or consumer is not very robust, and we have also the memory chip constraints that will extend to next year. So consumer electronics could face even more pressure. So just look at this number, you will know what I'm talking about. Like now with the AI boom and the U.S. export control in place, that make American chip developers much more important to the TSMC in terms of revenue contribution. Over the past few years, you can see U.S. share continue to grow and China's share continue to decline. And actually, I've also, the most recent quarter, TSMC's North America customers already contribute to 76% of their total revenue, while Japan's revenue only 4%, and Europe and then Middle East combined only 3%. So you can see what kind of efforts they might put into. So overall, expanding into new geography always bring new challenges, culture, labor force, regulation, shifting policies, higher costs, and there are positive side too. If a company can overcome all these hurdles, it becomes more resilient and more global and open door to new business opportunities.
It's fantastic. Thanks so much, Tim Fang. We always enjoy your sharing your your new findings, especially you very appreciative for you to update the new list, the trend there in Arizona and in Japan. So because we are running out of time, so we have to directly enter into the second round. The second round we are discussing about the possibility for collaboration. So this is I just mentioned in the opening part, like whether the collaboration between these three countries is possible, and if the collaboration is possible, what kind of a framework is potentially be created in this region, and who are the stakeholders to be participating in this collaboration framework. So this round I'm a little bit changing the sequence. Maybe firstly I'm having Tim Fang to share your perspective.
Okay. Thank you. Also have some very small slides for the session. And first of all, I really appreciate Professor Wakabayashi talk about the triangle. Actually, you can see the map here. It's Japan, Korea, and Taiwan is really a triangle. And then everyone, like both of you, Professor Kwon also talk about the triangle, and then I don't need to mention much. You can see Japan have what? Like essential semiconductor materials. Everyone already know, like no one can do advanced chip making without like photoresist from JSR or Sinetsu. And then Taiwan, we have very large scale logic chip supply chain, and then we have ICT, we have substrate PCBs, power supply, and we have a massive assembly. And Korea definitely is a global leader in memories, no doubt. DRAM, HBM, NAND, and strength in a lot of things, batteries, displays, and so on. So I just want to talk about because the second part should be about the collaboration. So in reality, any form of, the business side already have a lot of collaboration, but in reality, any form of like legal framework is difficult because of some geopolitical reality. So I don't think government to government cooperation among Japan, Taiwan, and Korea is always easy. However, from the business and the private sector, collaboration, like I said, happening naturally and already exists very long. And in many areas, the ties are very strong. So Japan and Taiwan always have very complementary supply chains. Taiwan focuses on semiconductor and ICT manufacturing, and Japan has a lot of the materials, and Korea also very important. So if you look at this simplified chart I make for AI data centers, you can see all the players, like key players within the supply chain are basically either from Taiwan, and this is not a complete chart, it's just a very simplified chart, and basically it's mainly focused on Taiwan. So it's a very simplified chart, and then, but you can find still, it's all from Japan or Taiwan or South Korea. So you can see how we are so important in this new AI hardware supply chain. So really, I think ultimately the companies that really driven supply chain changes and are the big chip makers or the major users that have a big purchasing power. Players like TSMC can play key role. Players like Samsung or SK Hynix, or their customer like Apple, Nvidia, Broadcom, Google, Microsoft can really driving the whole supply chain. The challenge is whether these companies can trust each other and how they balance the competition with cooperation. So TSMC, for example, have become much more involved with their supply chain management since the unprecedented chip shortage. It now works with much closely with a lot of suppliers and try to qualify more of them. One example I want to mention is that TSMC went 2-3 layers upper to work with like material suppliers like Daikin on like fluoropolymers, which are the key raw material for the tubes and valves used in chip plants and chip equipment. And TSMC also partnering with more Taiwanese equipment makers to build customized tools for advanced packaging. So I think they are also strengthening a lot of relationship with material makers as well. So actually, but I want to mention that Taiwan and South Korea's relations are also changing for many years. If you ask Taiwanese tech executives, actually they would feel like they are more competitions more than partners. But the situation changing, like Jeremy mentioned, TSMC now actually is helping SK Hynix produce their basic logic die for their advanced HBMs, and then also TSMC is handling advanced chip packaging. So they are taking in HBMs from Samsung, SK Hynix, and Micron to put together with NVIDIA's AI GPU. So I just want to say that supply chain is really long and extremely complex. Sometimes just a small incident like involved far away can cause a lot of disruption in the supply chain. If you remember currently the Nexpedia thing, actually they are building very legacy nodes, components, but they can disrupt a lot of car production for Honda, for Bosch, and a lot of them. So just for example, like when we try to put together a map of the supply chain for fluoropolymers and hydrofluoric acid and various like fluorine-based gases and components, we quickly realize how completely like complex it is. So I think at a time when countries are trying to weaponize and secure their own supply chain, this become a major challenge. Like I still think that no country have everything. And remember, I show here the chart is only on one chemical. And there are like thousands of materials and chemicals needed for chip making. And not to mention in advanced chip making right now, it's 1,000 steps. And you need to use a whole lot of things. So I don't think any nation can be fully self-sufficient. China is trying, particularly because of export control, but it's extremely difficult. So we recently also like interviewed Pat Gelsinger is Intel's former CEO, and he is someone who strongly supports U.S. onshoring and supports this supply chain resilience. But even he talked about U.S. is start to improve, but the meaningful results really will take decades. It's not years, and then it will require very long-term commitment of industry people as well as a lot of initiatives.
Tifan, thank you so much. Yeah, and next round, I'm inviting Professor Wakabayashi to mention your perspective. Especially, you mentioned Taiwan is facing 5 shortages, and we are jointly facing a lot of shortages currently. So from your perspective, what kind is the possibility for us to collaborate with each other for countering these challenges?
Okay. So I want to deeply discuss. So I cut my position talk. However, long position talk. So just cut my skip. So this is a dual silicon triangle. This is a functional division among nations. And the other one is the comparison between the Japan, Korea, Taiwan, China, US, how is the technology situation. Next is the business models. So the materials, SP, fabless, IDM, foundry, OSAT, EMS. And below that, the average turnover, Japan, US, Korea, it's a very link from the turnover. So next is how the Korea enters the semiconductor industry, in the case of Taiwan and so on, and China is how is. So this is more important. So you know that Taiwan have 5 shortages. So and then, Japan, Taiwan cooperation in the equipment of public foundry. So then I said, the Japan have, Taiwan have the 5 shortages. However, Japan can contribute to sub-shortage. So not only the 5 shortage, but also the data center or birth rate of rare earth is important. And then from now on, in Japan, the hot topic is science park. But from now on, the data center has been necessary in the science park. Then Taiwan 5 shortage plus 3 additional shortages. So the and Kyushu strength in the water electricity in here. And then, as you know, the Kyushu area is almost very close to the Taiwan, and we have the same risk over supply chain and the same geopolitical risks. So then, furthermore, I phrase the Huawei have a big base station market share. So if in data centers, if Huawei covers the areas, so some operation over the AME is difficult. That means the more in 6 years, the technology is changing. So then I introduce global supply chain ecosystem, not only in Japan, but Okinawa and Kyushu is necessary. That's all. Thank you very much.
Thank you so much, Professor Wakabayashi. So Professor Kwon, and the floor is yours. So keeping sharing your perspective.
So would you please open my PDF instead of PPT? PDF file. Yep. So, yeah, maybe page 15. Yep. So I stop there. And let me talk about the substantial technological collaboration among the 3 nations. So actually, we can define this kind of collaboration as some kind of comparative collaboration or a collaborative competition, whatever. But it means that we are facing a common technological problems in a variety of areas, including the computing, memory, energy, and sustainability. So first, I would like to talk about the first solution, as I said, which means that we can rely on the advanced accelerator facility located in Japan. So it means that we can develop the next generation light sources, including the short wavelengths or some free electron and the other the E-beam lithography, something like that. And it means that we can rely on the materials and the fundamental science facility in Japan, and we can invest some money and we can collaborate on this Japanese facility. And it means that we, the Taiwanese people and the South Korean people, can work together at the Japanese facility to develop the next generation light sources and the next generation, the mass production compatible light sources, something like that. Okay, can I have, okay, thank you. And I'll mention that. And I'd like to mention what is the new government of the South Korea ready for this international collaboration. So you may remember that a few years ago, the former administration have already announced the big project, which is called the Semiconductor Mega Project, which will be located in the southern part of the Gyeonggi province, which is highlighted over there. And Mr. Lee Jae-myung, so the administration also would like to invest more money about this kind of expansion and the advancement of the mega structures. But this is not just about the semiconductor fabrication. So this is about the formation of the international ecosystem for the development of the advanced system, including AI chip or some high-performance computer and the other next-generation computing. And it means that we can accommodate the international R&D center, definitely including the Taiwanese companies, universities, research institutes, to develop the next-generation technology. And there's some kind of the substantial collaboration cases among the 3 nations, such as kind of the advanced packaging facility. For example, SK Hynix still rely on the TSMC's packaging, the technology such as CoWoS technology, which is really critical for the fabrication of the HBM. And I think that we are also making some kind of a collaboration about this kind of the 3-dimensional fabrication compatible techniques, and which can be dominated by some kind of the facility companies located in Japan. Okay, and the second, in the second solution of the South Korea for the other countries is that maybe we can use this KSMC as some kind of the research and development specific fab, which is not for the mass production like Lapidus, but we would like to say that this is not just a 2 nanometer or 3 nanometer fab, but we would like to use this KSMC fab for the development only. And it means that we can test some equipment or materials and the other related technologies. And this is not confirmed yet, but we are pursuing the installation of the KSMC, and we will follow the former good example, which is actually TSMC. And the TSMC was founded by the Chinese government about 30 years ago, about 40 years ago. And they just make some kind of the privatization. And it means that we can follow the previous good example, and it means that we can make some kind of the international collaboration supporting facility. Okay, the third solution is about the combination between AI and the semiconductor. As you may know, the AI chip will require more and more energies as well as some technological the advantages. And it means that there should be some kind of the research hub. And we can also follow some good example, which is actually located in the PRC, the Beijing AIA, PAAI. And we would like to use this example, but we would like another democratic, the government, the operations, and the further the technology development and the standardization and the safety issues and the meeting the global regulation, especially for the safety, the usage of the AI. And I'd like to mention that the KAI is also specific for the building the full life cycle test and the certification hub for the sovereign AI. Although the sovereign AI is mentioned is about the nationality, but this is not necessarily limited for the nationality, but this kind of the independence of this AI-driven technology to other countries such as China. And we can enhance the efficiency of the end-to-end management of the IP related with AI. And ultimately, we would like to use this AI model not just for IT. It means that we can apply this AI model for some conventional manufacturing industry, such as shipbuilding and machineries and the petrochemical industry, something like that. And this means that there can be some AI-driven transformation, and there should be some strong bridge between this conventional manufacturing industry and the AI industry. And this can be intervened by the AI-specific chip. Okay, so this is going to be some KAI. And finally, I'd like to mention the next generation collaboration. So I remember yesterday's the closed room the discussions about what will be the potential collaboration areas. So definitely the quantum computing can be involved in this potential collaboration subject. But the problem is that nobody knows that when there's well really realized, okay? So there is the potential in the market growth, and there can be some potential for the profitability, but the thing is that there's still uncertainties for the technology. So we are still limited by the few hundreds of the qubit, and it means that we need to make some kind of error correction, and we need to make a use of this quantum computer, not just the encryption or decryption, but for the general purpose computing. And it means that there can be some hybridization between the quantum computer and the classical computer as represented by the Q-Link recently developed by the NVIDIA. But we would like to go beyond this kind of the hybridization. It means that there is the function of the computation. Okay, and finally, there should be another the candidate for the future computing, which is actually probabilistic computer, not just quantum computer. It's some kind of this middle, the mixture between the classical computer and the quantum computer. And we will use this P computer for the advanced, the combinatorial optimization to find out the better design or some kind of the optimization for the new materials targeting for new semiconductors. So this is all. So that will make my conclusion. Thank you.
Thanks so much, Professor Kwon. This is so remarkable. Yeah. I believe you are going to receive a lot of the quotes from our media friends here in Taiwan, especially the concept of KSMC. But I always want to emphasize that we should look forward to more on our complementarities. We are about to run out of our time, but I still want to accept one question from our audience. So if there's anyone have a question, I see Professor. Yeah. Sorry, anybody can pass. Oh, there's a microphone on you. Yes.
Hi. We talked a lot about the hardware related. We recently noticed that, for example, China's open source model like Qianwen or DeepSeek is actually quite adopted by countries in like southern country or even data center in Malaysia. They have like 70% of that. So besides the hardware-related co-work, what about the software service or AI model type of co-work? I think that is also quite important. Do you have any opinion about that? Thank you.
Any of our panelists want to answer the software part? So language model or AI training, sorry. Team from or the software, yeah.
About software, Japan and Taiwan, Korea is lack of software, especially EDA. So you know that EDA is monopolized by USA, Cadence, Synopsys. And all days, Japan have a little bit strong in EDA. But today, Japan only EDA about analog EDA or PCB EDA or components. It's important. So we try to, in JST, new Edge Semiconductor project, we take that project, we'll start. I think that why that Taiwan is very strong in the foundry is fabless. It depends the fabless. So there are I know MediaTek is always in 2000 is very small company, and I think the TSMC support many startup companies. IP is important. So that to try to important. So in that means in Japan, the analog EDA is supported by very small company or medium class company, and almost on the table. So it's we take IP or contribute the platform in necessary. I think okay. And more, I think that about the impact of the chiplet. The chiplet is we can reuse of the many IPs. So its approach is traditional, but not the traditional semiconductor design approach, but also OSS or software approach is capable. It's a very important impact on the semiconductor industry in design.
Yeah, sure. Besides Moore's law, the more and more approach is going to create a new frontier, a new possibility for this region to develop in software as well. I think, Professor Kwon.
So I understand your question about the software competency in China, right? So focusing on the semiconductor industry. The one of the representative examples in PRC nowadays is as EDA software, as Professor Hideki Wakabayashi mentioned. And actually, this should be some kind of the copy of the Synopsys or Cadence EDA software. So it means that one of the examples is the Empyrean, the software, and its software is totally comparable with the previous version of the Synopsys and Cadence. That is the point. The other point is the Moore thread, Musa. And the Musa is some kind of the copy of the CUDA. And this means that they can use the Moore thread Musa software or some API environment for the ASIC development or some even GPU-based design. And it means that they can rely on this Chinese version of this CUDA or some Chinese version of the Synopsys software. And the final example should be Huawei. And they would like to combine this AI model, not just AI model, but as I mentioned, they would like to make some transformation of this AI model for more industry-specific software, including AX. So one of the examples is actually Bao Steel in China, and they just constructively use the Huawei's AX model. It means there's some kind of the fine-tuned model-based software to operate the entire facility and the production line in the steel making. So that's all I would like to mention.
Tim Bang, you have anything to reply or? Okay, yeah, thank you so much. Because we are really running out of time, so please give a round of applause to our participants. This is a very, very informative sessions, and looking forward to further exchange with all our distinguished speakers there. Okay, thank you so much. So we're having 10 minutes for the
We'll
rest.
now take a 15-minute break.